Hi ladies and gents, we are continuing on here with this problem, the trees example in Anova. So we were looking at, is there a difference between the average height of the trees of Alberta, BC, and Ontario trees? And so this was what we looked at in the last video. So we did a hypothesis test of mu for A is equal to mu for B is equal to mu for O against the alternative that at least one differs. We went through all these calculations here and we found out that the F star value was 22.41, which is greater than the critical value of 4.26, and so we reject HO. Now, all that we've said at this particular point is that at least one of the means differs from the other. So which one is it, or do they all differ from each other? So what we want to look at now is this thing at the very bottom of the previous page, page A7, which is the multiple comparisons of means. And we have to take a look at each pairing of variables. I'm going to do that over here on the side here. I probably should have left myself a little more room, but we'll be fine. Here, let me put P value over here and then just get rid of that. So I'm going to use this spot over here. Okay, this is how the thing works here. So we're going to do Alberta versus BC. And the formula that we're going to use is this guy up here, where we're going to use just replace the subscripts here for Alberta and BC. So this is how the thing works, is we take a difference of means here. So this is the mean, the sample mean of Alberta trees minus the sample mean of BC trees plus or minus a t-statistic, which is based on alpha over 2 times, and then what we've got here is nt minus k is the degrees of freedom for this t. And then times the square root of, and then going back up here, we've got SSW over NT minus K. And then there's actually an adjustment here for, that's plus, yeah. For the two provinces. Now, in our particular case, actually, the N for the provinces is the same in each case. So there's 4 trees for Alberta, 4 trees for BC, and 4 trees for Ontario. But what we've got here is a difference of means plus a margin of error. This is actually just a confidence interval for the differences of means. Now we've got all of these numbers here, except for this guy here. Well, we don't have the X bars, but they're easy to find. But let's get this guy right here. So this is going to be a t 0.025, because we'll assume an alpha of 5%, right? 95% confidence, and so an alpha of 5%. And then nt minus k was 9. So it's always your degrees of freedom of SSW. It's always in the denominator of your F star formula. So it's NT minus K. So let's go to a T table and look for, under the 2.5% column, and 9 degrees of freedom. So let's go down there. Like that. Here's a T distribution. Here's 9 degrees of freedom. And there's our number right there under the 2.5% column. So it's 2.262. All right, now let's take a look at plugging in these numbers here. So the mean for A is is just, of course, the sum of the values for A. So it's actually the CA value. Oh, let me change colors here. Over the NA value. That's all it is, right? So we summed up those guys to get, what was it, 178, I think it was. So it's this guy up here at the top of the page. So 178 over 4 minus, and then for B, it was 331 over 4, plus or minus 2.262 times the square root of SSW. We've calculated the SSW to be 886.5 over 12, oh, not 12, 9. That's NT minus K is 9. And then times 1 over 4 plus 1 over 4. Because there's 4 Alberta trees and 4 BC trees. Okay, so let's just take a look at this. 178 over 4 is 44.5 minus 82.75. And then plus or minus, and this thing works out to be 15.87, like that. All right, and then I'm just going to go a little further here. So this is minus 38.25 plus or minus 15.87. And we can then, that would give us a lower bound of 54.12 plus or minus a margin of error. Oh, sorry, that was the margin of error. Sorry, that was the lower bound, and then the upper bound is minus 22.38. Okay, and we can write this as a probability statement that goes like this. Okay, let's explain this. Now, what we had was the Alberta trees on average, let me change colors here, were 44.5 feet, so 44.5 feet high. The BC trees on average were 82.75 feet. So the difference is just over 38 feet. So what that 38.25 is that is the average difference in height between Alberta trees and BC trees. So in other words, the BC trees are on average, or the Alberta trees are on average 38 feet and a bit shorter than the BC trees, plus or minus a margin of error of about 16 feet. So when you take the minus 38 feet plus or minus 16 feet, you end up with 54, minus 54 and minus 22. What that's saying is that Alberta trees are anywhere from 54 feet to 22 feet shorter on average than BC trees. Okay? Do you want me to write that? So we'll put down that Alberta trees are, on average, between 54 feet and 22 feet, of course there's some decimals there, shorter than BC trees. This is 95% confidence. All right. This is what you look for, is if there was no significant difference between the heights of the trees, what you would end up is a negative value here and a positive value here. In other words, the interval would contain 0. But when the two signs are the same, which is what we have in this case, then that means that there is a significant difference between them. In our case, because we had Alberta minus BC, we ended up with two negative numbers. So we're saying that Alberta trees are significantly smaller than the BC trees on average. And so the two signs are the same. Now, of course, if we'd taken BC minus Alberta, if we just switched them, you'd end up with two positive values there. And so if the two signs are either both negative or both positive, then that interval does not contain 0. And that means that there is a significant difference between them. However, if you end up with a negative value for the lower bound and a positive value for the upper bound, then the interval of the difference of means contains 0. And that means that there's no significant difference between them. What I want you to do for homework is to do Alberta versus Ontario, and then on BC versus Ontario. And what you find out actually is that Alberta and Ontario will be also significantly different, and BC and Ontario will not. You'll end up with a negative and a positive in that interval. And we're going to take that up in class. And then for homework, I want you to do the whole thing again, the Anova problem and the differences of means for this particular example right here. I want you to notice in this case that the ends are different. So we've got 1, 2, 3, 4, 5 A's, 4 B's, and 6 C's. And so there's a difference there in terms of the number of values there. All right, so do the Anova problem, work through all the numbers, and then also do the difference of means, and we'll take that up in class. And that's the main test in this particular unit, but there's lots of other stuff that we will get to a little bit later. So I'm going to end that here. Thanks for listening.